Now I am recording our lesson, and now I am sharing or attempting to share the screen. Today is Tuesday, October 6th at 1:52 p.m. in 4th block, room 409, Liberty High School, Bethlehem, Pennsylvania. And I'm here with my Principles of Engineering class, which is the second course in the Project Lead the Way engineering program. And what I'm trying to do at this moment is teach, which is unusual, I know. I'm trying to teach a particular lesson in solving these circuits. And one thing I want to point out about solving these circuits is anytime you have a circuit, anytime you have a circuit problem, you have to completely solve the circuit. And what I mean by completely solve is that anything that's unknown about the circuit, you have to find. And so let me just start with number one. For each of the resistors shown below, use Ohm's law to calculate the unknown quantity. Be sure to put your answer in proper engineering notation and use the correct units. So it's basically physics, and we're going to use the guess method. Kevin, if you remember, G is for given, U is for unknown, E is for equation, S is for substitution, and the second S is for solution. Close that laptop, please, Matt, and look at my big screen. So number one, the first thing I want to do, or probably the only thing I want to do, is draw the circuit itself. And I know that you see the circuit is drawn vertically. I'm going to try to perform less for the video and just talk to you guys more. I apologize for that. So I have to draw that circuit. And I don't like that it's drawn vertically, but I can change that. I can draw it. I'm looking at the screen while I'm doing this. I can draw a circuit horizontally. It's the same circuit. And so draw this, squiggle, 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 draw that. And then there is a point there. So this is not really a complete circuit. It's really just a piece of a circuit. And they do give us the resistance here, which is, the resistance is 470. That symbol is an omega. 470 omega for 470 ohms. Ohm is the unit of resistance. And then they also give us a voltage. The voltage is equal to, please correct me if I make an error here. I'm trying to look through my glasses and they work like for far away, but they don't work for close. And so the voltage that we're given is 3.5 volts. The unit of voltage is volt, which is convenient. Think of resistance as resistance and think of voltage as pressure. And so what they're asking for here, I guess I can't point over here if you can see that. They're asking for I. I is the current. I don't know why the variable, I don't know why the variable for current is an I. The variable for resistance is an R, and the variable for voltage is a V. And so with this, I'm still learning, everyone. I'm still learning. Okay. Okay. And so there are your three quantities: current, resistance, and voltage. And there is an equation that puts all these together, and that equation is actually Ohm's law. Ohm's law is just the equation V equals IR. And what's interesting about this equation is you can turn it into three equations, which here is the first version, V equals IR. And if you would like me to figure out the other two versions, I guess I can do that. If I'm solving for I can divide by R to isolate it. So I would get V over R in that case. I hope that makes sense. It's algebra. And then the third version of this equation would be for the resistance. And if I'm solving for R this time, then I will divide by I. So that would be the voltage divided by I. Okay, so if you don't need that, well, then this is Ohm's law. This is actually Ohm's law. These are just two derivations of Ohm's law. And so if you're trying to solve this current right here, well, which version of this equation would you like to use? This is actually Ohm's law. There's a lag here. This is actually Ohm's law, but this derivation of Ohm's law is more useful for finding I. And so I'm going to go ahead and substitute that. I equals, and then like Matt would say, I would put 3.5 for volts, and then divide that by the resistance, which is 470 ohms. Be very careful to watch out for prefixes. If you remember metric prefixes, sometimes there will be a kilo ohm, which means if it was 470 kilo ohms, then it'll be 470,000 ohms. Be careful of that. And then let me see if I can calculate the value of I in this case. So why don't you do it for me? Because I don't know what 3.5 divided by 470 is. So somebody, anybody, Jess or anyone else, calculate for me 3.5 volts divided by 470. 3.5 volts divided by 470. Okay, so it probably starts out with a 0, right? 0 point. Give me 3 digits only. 0, 0. Okay, give me 2 more digits past that. I didn't realize it was going to be so teeny tiny. Yeah, give me 2 more digits and round the fourth, based on the fourth. Okay, so is this what we got or close to it? 0.00475. When I asked Jess to give me 3 digits, I didn't realize that the first 2 were going to be zeros. So 3 significant digits, if you know what that means. And the unit of current is an amp. So the variable that we use there is A. I like to draw boxes. Boxes are fun. I like to draw boxes. So that helps me out if you draw that box. That is a circuit calculation. Yes. Yes. And so I'm going to let you do number 2 and number 3 on your own, or not number 2 and number 3. I mean, yes, number 2 and number 3, but the other 2 that are part of number 1. That's only 1 of 3 in number 1. So go ahead and work on it if you're ready for that. I'm going to stop the recording now and see if this actually worked. Yes, go ahead, Jess.
Why was there? Wait, go back to the.
Okay. Well, this I'm gonna cancel that. Cancel. I'm going to include Jess's question in the video and in the Schoology conference.
Why is there like 15.51? Why is there a little letter next to the A?
Ah, yes. Good question. There's a little tiny, looks like a U. Looks like a U, but it's not a U. Looks like a U. Let me try and make that a little larger. Nothing's happening. Why is nothing happening? Okay, did I do that right? Okay. All right, that little, it looks like a U. That actually is not a U, it's a mu. It's a mu. So think of mu and think of U and put them together and you get mu. Mu is a Greek letter, that's a lowercase mu. And so that means micro. It's a microamp. Now you already know what a milli is, right? A milli is 1/1000th. Well, a micro is 1/1,000,000th. So a microamp, you would take the value that they gave you 15.5 and divide it by 1,000,000, and then that would give you the value for I. Does that make any sense what I just said? Okay, and then thank you. Oh God, thank you. And then also, you notice there's a K on this one. You probably know K without me telling you. Kilo, that's right. Kilo ohm, so that would be 22,000 ohms in that case. And then notice this one's got a little M. You remember what a little M is in the metric system, which is, that's right, it's a milli. So you divide that by 1,000. You multiply kilo by 1,000. You divide milli by 1,000. And you divide micro by 1,000. I mean, by 1,000,000. Micro is divided by 1,000,000. By the way, there's something called a meg, which is when you multiply by 1,000,000, or a gig when you multiply by 1,000,000,000. And there's also a tera, if you've heard of a terabyte. But I'll stop there. Yes, exactly. And kilobyte. Yeah, okay. Anyway, right. I'm going to stop sharing. And this time I am going to stop the recording. But that was a good question to include in this recording. Bye-bye.